Hi guys, so welcome back. We are going to start talking about graphing relationships today. So we are moving on to chapter 4. So we're going to have graphs that relate to certain situations, and we'll have to have a graph and then decide what our situation is, okay? So let's talk about this first one. So it says the temperature was constant for several hours at the beginning of the day, then rose steadily for several hours. It stayed the same temperature for most of the day before dropping sharply at sundown. Choose the graph that best represents this situation. So I want you to go ahead and decide, based on that situation, which graph would best fit this. Okay? So when we're deciding this, we want to read the graph from left to right. So we're seeing what's happening. So we're kind of staying the same, then going up, then going back down, and then staying the same for a while. Okay? Again, was constant. That means it's staying the same for a while. So it's a horizontal. Rose steadily means it's going to be slanting upward for a little bit. Stayed the same, that means, again, a horizontal line, and dropped sharply means slanting downward. So it says the temperature was constant for several hours. So I know I'm going to have a straight line. So we can immediately eliminate graph C because it doesn't have a straight line at the beginning. It goes up right away. Okay? And then it says at the beginning of the day, then rose steadily for several hours. So it stayed the same and then went up. So graph A or B is still in. And then it says it stayed the same temperature for most of the day. So we like the straight line, we like the up. But then this one doesn't stay the same for very long, and this one does, okay? And then it says dropping sharply at sundown, so it's going down, okay? So graph B would be our best representation of that because it has the flat where we stayed the same temperature for most of the day. So that's a long time, okay? So that would be graph B for the correct graph, okay? All right, we're going to talk about discrete versus continuous data, okay? So discrete data is where there's very distinct points. So there's no in-between data. So like if I were to look out the window right now and count all the cars passing that were white, I'm not going to have 1.35 of a car, okay? So if we don't have that, then that's discrete. Continuous data is data that has the in-between or it's connected by lines or curves. So like if we're talking about height, you can be 5.62 inches tall, right? Or you can have degrees, right? It can be 63.5 degrees, okay? So if we can't get that in-between data, it's discrete. If we can, it's continuous. We have Spencer is selling candles to raise money for the school dance. For each candle he sells, the school will get $2.50. He has 10 candles that he can sell. So we're going to graph this, and we're just going to do kind of like a general graph, okay? So I know that he is going to sell so many candles, okay? That's the variable he can control, which is why it's on the x-axis. And then the amount of money he has is going to go here. So I know that when he sells one candle, he'll make $2.50, right? When he sells 2 candles, he'll make $5, right? And when he makes 3, so on and so forth, right? So it's going to kind of go like this. Okay? That's oddly spaced, so we'll just erase that one. So now we need to decide, once we've graphed it, is this discrete or continuous data? Okay, and I want you to decide, is it continuous? Continuous, I can't write, guys, today. Continuous or discrete, and I'll have a question off to the side here. Okay. And this would be discrete, right? Because I can't sell half of a candle, right? There's going to be no data point right here because that's half of a candle. That doesn't work, okay? So it is, in fact, discrete data, okay? All right, let's try another one. Anna's heart rate is being monitored while she exercises on a treadmill. While walking, her heart rate remains the same. As she increases her pace, her heart rate remains... Oh, I think that is doubled there, okay? As she increases her pace, her heart rate rises at a steady rate. When she begins to run, her heart rate increases more rapidly and then remains high while she runs. As she decreases her pace, her heart rate slows down and returns to normal rate, okay? So we're going to graph it. So we have... how far she's going, right? And then her heart rate. Okay? Because again, she can control how far she goes, right? She can't control her actual heart rate. Okay? So it says, while walking on her treadmill, her heart rate remains the same. So she's starting somewhere over here, right? As she increases her pace, her heart rate rises steadily. Okay? So we have a nice rise steadily. As she runs, it increases more rapidly, so that would mean I'm going to make my line go up a little bit faster. Okay, and this is just a rough sketch. It doesn't have to look perfect. And then remains high while she runs. So she's going to keep running for a while, and it's going to go up, right? Or stay the same, I'm sorry. And then as she decreases, her heart rate slowly goes back to normal. So it's going to go back to normal like this. Okay, so that's the graph of that one. Now decide, is that continuous or discrete? Okay, and this would in fact be continuous because again, I can have those middle grounds, right? Her heart rate could be at 150.3, right? And we can see that we have even lines here instead of dots like what we did with Spencer's selling candles. Okay? All right. So this next one, I guarantee you there will be a question like this on the test. Okay? And this is really hard one for students sometimes. It has to make sense. So if it tells me that this graph is about water level and you start talking about something weird like running, like Anna running, that makes no sense. So make sure you actually read the graph when you do this question, okay? So it says write a possible solution for the graph, okay? So we're identifying the labels so we can see that this is time, so how long we're there for, and the water level, how high it gets, okay? So make sure when you're writing something about this that we're talking about water level. And we could have a myriad of situations here, okay? So we can see in the red it's increasing steadily, the blue it remains unchanged, and then decreases steadily. So I might say we have a pool and we're filling it up for the summer, right? We're gonna fill it up in the summertime, at the beginning of summer, right? It's gonna stay the same throughout the summer for the most part, right? And then it would go down in the fall when we let all the water out. That would be a good example of that, okay? Maybe it's a tub. You're filling up the tub. It stays the same while you're in the bath, and then when you pull the drain, it decreases steadily, okay? This could be anything about water, right? Maybe it's your water bottle. We're filling up a water bottle. It stays the same while you're at school because you didn't forget to drink it, and then when you dump it out because it's gross tasting, it's going down, okay? As long as it's talking about water of some sort and the situation makes sense, okay? So if I was talking about like heart rate here instead, I would say, oh, as they're running, their heart rate goes up and it stays the same as they continue to run at the same speed, and then it goes down as they get closer to home because they have their cooling off period. That would be acceptable if the label had been heart rate, okay? So please, please, please make sure you understand how to do this because there will be a question like this on the test, I promise. Have a wonderful day and we'll talk to you tomorrow. Bye.